In this example, a block of weight W is being pulled to the right by a force P. So first we'll draw the block and across a rough horizontal plane, so it is, and draw a force diagram to show all the forces acting on the block. So the weight typically downwards, as also impacted by gravity, and the reaction, it will be upwards in the opposite direction of the weight, and the force that is pulling is P in this direction to the right, and also there is friction in the opposite direction to the plane, and this is the force that we will also need to consider impacting on the body. So these are the forces that we will need to consider. In this example, the diagram shows the forces acting on a particle. For part A, we need to draw a force diagram to represent the resultant force. So forces horizontal, because they're opposite direction, they will be taken. Forces vertical, that will be 30 taken away from 10, and that will give us 20 Newton. So in this scenario, the body will be represented in this format, and this will be the resultant force. For part B, we need to describe the motion of the particle. So it is accelerating, and this will be our answer for this question. In this example, a box is at rest on a horizontal table. Draw a force diagram to show. In this scenario, you can see we have a body on the plane, and we have the weight acting on the box, which is going downward, and the normal force reaction is upward, which will be opposite to the weight, and this will be the forces acting on the body resting on it. This will be the answer for this. In this example, a trapeze bar is suspended motionless from the ceiling by two ropes. Draw a force diagram to show the forces acting on the ropes and the trapeze bar. So our explanation, so this is the trapeze wall, and the force is pulling, which is in this scenario, the strings or the ropes pulling the body upward, and the weight pulling downward. So this is the distribution of the forces acting on the trapeze bar. In this example, ignoring air resistance, draw a diagram to show the forces acting on the apple as it falls from a tree. As shown here, we have the body without forces acting on, which is in terms of a rope or only force that's pulling the apple upwards. So the only force acting is the weight of the apple, which will be downwards because the forces which is impacted by the gravity, and this is the only force. In this example, a car's engine applies a force parallel to the surface of a horizontal road that causes the car to move with constant velocity. Considering the resistance to motion, draw a diagram to show the forces acting on the car. So in this scenario, we place the vehicle on the horizontal plane, and we have the weight acting downwards and the reaction upwards, and the force pulling in one direction, and we have the force F, which is the frictional force of the car, and P is the force which is produced by the engine driving the car in let's say forward. And this will be our explanation in terms of the forces acting on the vehicle. In this example, an air-sea rescue crew member is suspended motionless from a helicopter. Ignoring air resistance, show all the forces acting on him. So in this scenario, we have the force, which is upwards, the tension in the rope, and the force and the weight of the rescuer, which is going downwards. So this is mainly the vertical forces acting on the. In this example, a satellite orbits the Earth at constant speed. State with a reason whether any resultant force is acting on the satellite. So our explanation in this scenario, that although its speed is constant, the satellite is continuously changing direction. This means that velocity changes, therefore there must be a resultant force acting on the satellite. And this will be our explanation for this question. In this example, a particle of weight 5 Newton sits at rest on a horizontal plane. State the value of the normal reaction acting on the particle. So since the weight sits on a horizontal plane, which will act downward, the normal reaction will be equivalent to it, and because it's at rest, will be equivalent to 5 Newton. In the opposite direction, in this scenario, will be upward. In this example, given that each of the particles is stationary, work out the values of P. So first we're looking at part A, on a force down upward vertical forces. So we will be P taken away from 10 0. So that means the value of P will be the answer for part A. For part B, we have 10 Newton upward, 10 Newton downward, and P on the right hand side 90 Newton. So we look at the horizontal forces, which will be P in this scenario taken away from 30 equals 0. So that means the value of P will be 30 Newton. For part C, we have 10 Newton upward, 10 Newton downward. They cancel each other. While we look at the horizontal forces, which will be on the left hand side 15 Newton, on the right hand side P and 1.5 P. So the way we would look at this, mainly the horizontal forces, we'll start with P plus 1.5 P minus 50, because the P's on the right hand side will be added while taken away from the left hand side, equals 0. So that means we have 2.5 P equal 50, and this scenario P will be 50 divided 2.5, which will give us P being equivalent to 20 Newton, and this will be our answer for this. In this example, a hoist lifts a platform vertically at constant velocity as shown in the diagram. For part A, ignoring air resistance, work out the tension T in each rope. The tension in each rope is reduced by 50 Newton. So for part A, since the platform is moving at constant velocity, the total vertical force is 0. So in terms of looking at how we distribute how we find the tension, so we have a distribute across two locations, so it will be T plus T equal 400. So in this scenario, we define, because we have T plus T, that will be 2T, and we have 400 divided by 2, that will give us T being equivalent to 2. So the tension in each rope is 200 Newton. For part B, we need to describe the resultant motion of the platform. So if the tension in each rope is reduced by 50 Newton, there is a resultant downward force on the platform. It will therefore accelerate downward. And this will be our answer. It shows a particle acted on by a set of forces. Given that the particle is at rest, find the value of P and the value of Q. So first we will start, since the particle is at rest, both horizontal and vertical forces must be balanced. So we will start by considering the horizontal forces only in this scenario. So P take away 50 in the opposite direction equals 0. So that will give us P being equivalent to 50. So that will tell us we need to also look into the vertical forces acting on the body. So 5Q in the upward taken away from 10 plus Q plus 10, take away 3P, because that we are considering the negative forces, downward forces to be negative and upward forces to be positive, and we equate all these forces to 0. So now we need to rearrange this expression to 4Q minus 10 minus 3 multiplied by 50, as we found P in the previous example, and so we subbed P into the expression, and that will gives us as we simplify, 4Q equal 160. So now we divide Q equal 160 divided by 4, and that will give us Q to be equivalent to 40. So in terms of the values of P and Q will be 50 P, and the value of Q is 40. This will be our answer. In this example, given that the particle in this diagram is moving with constant velocity v, find the values of P and start by first, since the particle is moving with constant velocity, both the horizontal and vertical forces must be balanced. So we look at first the horizontal forces. So in this scenario, we have 2P plus Q and then 25. So now we will create an equation for Q, which will be 25 minus 2P. Then we will look at the vertical forces. So we have 3P minus 2Q on the upward, and we can sub the Q. So we have 3P minus 2Q equal 20. Now we substitute Q into the expression, so that will give us 3P minus 2 multiplied by 25 minus 2P equal 20. Then we rearrange the expression, that will give us 3P minus 50 plus 4p equal 20. So rearrange, move the p's to one side and numbers to one side. That will give us 7p equal 70. And then we divide, p will be 70 divided by 7, so that will give us p being equivalent to newtons. And now we can sub the 10 newtons into the original horizontal q equation, which will give us in this scenario 25 take away 2 multiplied by 10, so that will be 25 take away 20. That will give us the value of q being equivalent to 5 newton. So in this 10 newton, and the value of q is 5 newton, and this will be our answer for this question. Example, each diagram shows the forces acting on a particle. So for part A, we need to work out the size and direction of the resultant force. So first we look at A. In this scenario, the vertical, we look at the horizontal forces will be 100 take away from 100, that will be 0, and the horizontal forces will be 40 taken away from 20, so that will give us 20. So the resultant force in this scenario will be 20 newton upward. Now in terms of describing the motion of the particle is, we explained that it is accelerating vertically. For part B, in this scenario, again, we look at the horizontal forces will be 25 take away 5, that will give us 20, and for the vertical force that will be 0, so that will tell us the resultant force is 20 newton to the right. In terms of motion of the particle, we say that the particle accelerates to the right, and this will be our answer. In this example, a truck is moving along a horizontal level road. The truck's engine provides a forward thrust of 10,000 Newton. The total resistance is modeled as a constant force of magnitude 1,600 Newton. Now for part A, modeling the truck as a particle, draw a force diagram to show the flow. So first we will start by having the diagram, which will have the weight downward, the reaction, normal reaction upward. This is in opposite direction, Newton on the left hand side and then on the right hand side. Now in terms of how we describe the forces, so we have the normal on the reaction on the road, on the car, and we have the weight downward and the forward forces, and also the vehicle to the right, positive, and also we have. Now for part B, we need to calculate the resultant force acting on the truck. So in this opposite forces of 10,000 taken away from 16,000, and that will give us the resultant force to be 8,400 Newton, which is in the direction of travel to the right. I need to explain that there is no overall vertical force, as R and W must be balanced, otherwise the vehicle would lift off to the road or sink into it. And this will be our explanation in terms of we mainly focus on. In this example, a car is moving along a horizontal level road. The car's engine provides a constant driving force. The motion of the car is opposed by a constant resistance. As part A, modeling the car as a particle, draw a force diagram to show the forces acting on the car. So in this scenario, we'll start acting on the vehicle, which is the weight downward direction, normal reaction upward, which is driving the vehicle, and in this scenario, we have multiple forces acting on the vehicle, as we described in the normal, the weight, driving force, distance of the car is 4,200 Newton in the direction of the motion, and the magnitude of the driving force is 8 times. That's why we represented the magnitude of the resistance. So we need to now find the magnitude of the resistant force, because in opposite direction we have P equal 8F. So for us to solve this equation, we would have 8F, we need to represent both, so we'd have 8F minus F, because they're in opposite direction, will equal 7F equal 4,200, and then we divide 4,200 over 7, which will give us the value, which is the magnitude of the resistant force, and this will be our answer.